So let's explore the idea of equilibrium versus not equilibrium. Let's create a little side-by-side chart in our notes. There's no good physics word for not equilibrium. It's not disequilibrium or unequilibrium. It's just not equilibrium. And the state of an object being in equilibrium is that the net force equals zero. The vector sum of forces equals zero, which means you add up all the forces and they cancel each other out. So what is the case in not equilibrium? It just means the net force is not zero. What does that mean? Well, that means when you put all the forces together as vectors, something is left over. So what's the consequence of this? Well, that means that in equilibrium, the acceleration equals zero, right? Sigma F equals ma. If sigma F equals zero, the acceleration equals zero. So I bet you can guess on the not equilibrium side, what is that telling you about acceleration? Right, it's just not zero. So what does that mean? Well, in words, we could say that means it is accelerating. Some students like the words better than the symbols, right? If the acceleration is not zero, that means it is accelerating. So on the equilibrium side, what does that mean? It means it's not accelerating, right? The acceleration equals zero. So on the not equilibrium side, what does it mean if it's accelerating? We know there's three ways to accelerate, right? Just think that through for a second. I'm sure you know what they are, right? So either it's speeding up, or slowing down, or changing direction, or maybe even a combination of more than one of those things, right? In other words, something is changing about its velocity. Remember, velocity is motion, acceleration is how quickly motion changes. And so really anything on the right-hand side here is a statement of not equilibrium. They all sort of go together. If the net force is not zero, that means the acceleration is not zero, that means it is accelerating, that means something is changing about its velocity, it's either speeding up, slowing down, or changing direction. So what does it mean if it's in equilibrium on the left-hand side? That means it's just not doing any of those things, right? You don't have to write it again if you don't want to, you can just do what I've done here. It's not speeding up, it's not slowing down, it's not changing direction. Okay, does that mean it's not moving? Well, hopefully you realize not necessarily, right? All it means is nothing is changing about its velocity. So maybe it is moving. As long as it's moving at a constant velocity, the acceleration equals zero. Can it be at rest? Well, sure, that could happen as well. That's still a condition of acceleration equals zero. So either it's moving and it stays moving at a constant velocity, or it's at rest and it stays at rest. As long as nothing is changing, that's equilibrium. Again, the net force is zero, acceleration is zero. The confusing part is when you look at the free body diagram, when you see all the forces canceling out, you may be tempted to say, that object is at rest. Not necessarily. Maybe it is, or maybe it's moving with a constant velocity. Without more information, you really can't tell.